Hi everyone, so 10.1, I think you will be happy to see is a lot of the stuff we did in 10th grade, actually. So if we're taking a look at, oh, sorry guys, I need to plug in my pen. So if we're taking a look at our objectives, understanding points, lines, and planes, solving problems involving angle measures like supplementary, complementary, solving problems involving angles formed by parallel lines and transversals. If you remember, like alternate interior angles, same side interior angles, vertical angles, that type of stuff. All stuff we've done before and all stuff I think that comes back really easily if you've forgotten. So points, lines, and planes. Just go through and look at, look for the bold. A point represents a small dot, has no length, width, or thickness, right? A line connects 2 points along the shortest possible path, okay, like a straight line. A plane is a flat surface with no thickness and no boundaries. Those are quadrants, right? This page resembles a plane, although it does have that thick. I was just going to say that, the next part of that line. And then it just tells you how to write them. So a line can be symbolized either direction, right? As AB or as BA. And you know that's a little bit different if you look down below. You have, it has lines, but if you look in between the lines, those would be line segments, like AB. Here, line segment AB here on the end, which doesn't have the arrows below when you're talking about it. And rays are only going one direction, and it has a half line here. So just, spend a little time. If you didn't automatically remember what these were, I would suggest just reading it again and making sure you're looking at the pictures because we're going to be moving on to angles. And remember, we use this symbol for angles. You can find those in Google Docs under insert symbols. Let's see. So an angle is formed by the union of two rays that have a common endpoint, okay? The union of two rays that have a common endpoint. So if you look up here at your ray, it would be two of those that would both end at A, and obviously that would form an angle. That's all it's saying. I don't think we need to really get in the weeds about that. Measuring using angles. So, well, up here at the top, it's talking about a rotating ray is a way to think about angles. And all they mean by that is that angles are all part of a circle. So if you look at this figure over here where you have a clock, the clock is a circle. And all circles have a measure, a full measure, if you go all the way around, of 360 degrees. So you can think about angles as different pie pieces of a circle. In fact, I would suggest that's the easiest way to think about angles. So measuring angles, if we know that all angles in a circle add up to 360 degrees, it is pretty easy to measure them. So this example says the hand of a clock moves from 12 to 2 o'clock. Through how many degrees does it move? So if we know a clock has equal measurements between numbers 1 through 12, we have 12 different pie pieces, right? And we know moving from 12 to 2 is moving through 2 of those pie pieces. That's where they get this fraction over here. This is 2 over 12. Let me write that better on here. Okay, so they're saying we are moving 2 pie pieces out of 12 pie pieces. And then they reduce when they're actually doing the math. I don't know why they needed to reduce it if we're just using calculators anyway, but they did reduce it to 1 over 6. 2 over 12 is the same as 1 over 6. And so they just multiplied that by 360. So 1 over 6 times 360 is the same as 360 divided by 6. So we get 60 degrees. So the clock moving from 12 o'clock to 2 o'clock is moving 60 degrees. On checkpoint 1, the hand of a clock moves from 12 o'clock to 1 o'clock. So it's only going 1 pi piece out of 12. And that's the portion of the entire circle that it's moving. So finding the answer to that will give you that angle if it had only moved from 12 to 1. All right. Oh, and then here's some good definitions, but I know you're going to remember these. An acute angle is less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is larger than 90 degrees, but it says here less than 180 degrees. And a straight angle is exactly 180 degrees. You measure angles using a protractor, right? And then this next part is what we're going to do an example on. Two angles who have a sum of 90 degrees are called complementary angles. Okay, which means, and then they give a little example, 70 degrees and 20 degrees are complementary angles because they will add up to be 90-degree angles. If things add up to be 90-degree angles, that means you can find the measure by subtracting an angle's degrees from 90, right? The inverse operation to find something. So if we're looking at example 2, we're looking at figure 10.8, find the measure of DBC. So I can tell that angles DBC and DBA are complementary because we have that right angle symbol, which means that angle ABC is 90 degrees. If I know that DBA is 62 degrees, then I know that DBA is 90 minus 62, which would be 28 degrees. The checkpoint says, what if I know that DBC, so it's changing up the number. So now it's saying we don't know this anymore, but the checkpoint is saying now I know that DBC is 19 degrees. So what would be the measure of DBA? So of course, you would subtract 19 degrees from 90 degrees. We know, we just learned about or remembered about complementary angles are angles that add up to be 90. And the next thing we should remember, supplementary angles are angles that add up to be 180 degrees, right? So a straight line, a flat line halfway around the clock are supplementary angles. A quarter way around the clock would be complementary angles. So it's saying 110 and 70, those two angles would be complementary because they add up to be 180 degrees. So if things add up to be 180 degrees, you can find an angle measure by subtracting one, if they are supplementary, by subtracting the other angle measure from 180. The example they give is over here. Angle ABC is a straight angle, so that's 180 degrees, which means angle ABD and angle DBC will add up to be 180 degrees. Our question says that the measure of angle ABD, oh, this is a little bit trickier. The measure of angle ABD is 66 greater than DBC. So if we make DBC X, because we don't know what it is, we know that angles ABD is X plus 66. That's what they're doing in that problem. So it took it up a little bit. I bet we were feeling pretty good in that complementary angle stuff, and then it took it up a little bit. So that's okay. We still got this. So we know that if we add those together, X plus 66, they should equal 180. Combine your like terms. 2x plus 66 is equal to 180. We're solving for x, which means we need to get it by itself. So, and you could walk yourself through it. It's doing it for you. I just like to do it on my own. So we subtract 66 from both sides. So then 2x is equal to 114 if we believe the book. And the book is keeps putting degrees on these, just as long as you remember your answer needs to be in degrees. Then to solve for x, we divide both sides by 2, and x is equal to 57 degrees. So the measure of angle DBC is 57, but the measure of angle ABD is 57 plus 66, which is 123. Now the checkpoint says, let's go back and do the checkpoint now. I'll just do this. The checkpoint says, if the measure of angle ABD is 88 degrees greater than DBC, so if this is x, this would be x plus 88. Find the measure of the angle. So if we add those two up now, it'll be 180. So do the same exact thing that we just did. And you will be able to solve checkpoint 3. Okay, we're going to be getting into vertical angles. Okay, so when two lines intersect, the opposite angles formed are called vertical angles, and vertical angles are always congruent. They're always equal to each other. Okay, so on here, 1 and 3 are equal to each other, and then 2 and 4 are equal to each other. I think that's one of the easiest angle relationships to remember. So if we're looking at example 4, we're looking at figure 10.12, shows the angle on the left measures 68 degrees. Okay, find the measure of the other 3 angles. So if that angle is 68 degrees and angle 1 is also 68 degrees, and then here's the cool part, you guys. If we added them all up together, you get 360 degrees, right? So half of it, so angles 1 and 2 have to be 180. So I'm going to take 180 and subtract 68. And that means the measure of angle 2 is going to be 118, if I'm doing my mental math correctly. And if the measure of angle 2 is 118, then also, because 3 is vertical to 2, that is 118. Is that right? I don't think I did my mental math correct, because I think if I add 118 and 68, I do not get 180. I better use, why was I not able to do that in my head? 180 minus 68. 112. So stupid. Okay. Sorry, you guys. At least I caught it before anybody yelled at me. 112. 112 degrees. Good. Okay, and then I should go over the checkpoint with you. Oh yeah, there it is, if I would have turned the page. Checkpoint 4 says, assume the angle on the left is 57. So instead of 68, we have 57. Okay, find the measures of the other 3 angles. So that means 1 is vertical to 57. So I mean, I'll give you that answer. This is 57. And 2 and 57 have to add up to be 180, and then 3 will be the same as 2. All right. Parallel lines and transversals. Okay, so if we look at this figure, this line and this line, they don't have their lines labeled, I wish they did, are parallel to each other. And that makes the line crossing through the transversal. Okay, so if you look, what they want you to know, if you look at that, because these yellow lines are parallel to each other, that means that all of the angles, okay, are going to be exactly the same as the angles here. They're just going to be shifted down, but their measurement is going to be the same because those parallel lines have exactly the same slope. okay? So what that means is the alternate interior angles, so angles 3 and 6, which are on opposite sides of that transversal, but they're inside the parallel lines, so they're called alternate, the opposite. Interior means inside, obviously. And it says interior angles that do not have a common vertex on alternate sides of the transversal. Okay, I like my description a little bit better. Alternate interior angles have the same measure. That's the important part. Okay, so that means 3 and 6 are exactly the same, and that means 4 and 5 would be the same. Alternate exterior angles also have the same measure, so they are on opposite sides of the transversal, but this time they are outside of those parallel lines. Corresponding angles is exactly what I was talking about before. They are in the exact same place, but just on those different parallel lines, and they also have the same measure. They're all equal to each other. So what's cool about all of these different types of angles is it makes it really easy to figure things out once you know just one of them, right? And so I think that's what, and here's a little bit, I like the table, but here it has it written out as bullet points. However you want to do your notes is fine. Finding angle measures when parallel lines are intersected by a transversal. So it wants us to find all of the angles here, but we only know one. We only know that the measure of angle 8 is 35. But that gives us a lot. We know if the measure of angle 8 is 35, that the measure of angle 1 is 35 because they are vertical. We know that 5 is also 35 because they are corresponding. It's the same exact angle on a different line. And that makes 2 also 35 degrees because they are vertical. 2 is vertical to 5. And that means that angle 4 is supplementary. Those two angles are going to add up to be 180 because they're on that straight line. So let's see if I could do this in my head. What is 180 minus 35? 180 minus 30 is 150, minus 5 more is 145. And that makes 3 145, which makes 6 145, which makes 7 145. Okay, checkpoint 5, do the same exact thing, except the measure of angle 8 is 29 degrees instead of 35 degrees.